Our topic for today is sound and hearing. Dear students, what is sound? Sound is a form of energy that can travel from one place to another. Imagine clapping your hands or hearing a friend shout that sound, a type of energy moving through the air to reach your ears. Our ears can detect this energy. That is one way we can find out what is going on around us. Sounds come from traffic, machines, television, and radios. Some sounds are pleasant, others are noisiness, and some can be dangerous. Students, do you have any idea how sounds are made? Sounds are made when something vibrates. All musical instruments have a part that vibrates. So, sounds happen when things move and shake. When something like a guitar string, vocal cords, or a drum surface moves back and forth, it makes the air around it move too. This movement creates sound waves that travel to our ears and we hear them as sounds. In a guitar, it is the strings which vibrates. When a drum is struck, its surface vibrates, producing sound waves that resonate inside the drum and then travel outward into the surrounding air. When you speak, your vocal cords vibrate as air passes through them, producing sound waves that form words. Even a singer's vocal cords vibrates. How sound travels? Sound can travel through the air. If we are listening to a drummer, we do not have to put our ears on the drum to hear the beat. Imagine you are at a concert listening to a drummer in a band. You do not need to put your ears right on the drum to hear the beat. Why? That's because sound can travel through the air. The sound from the drum travels through the air to our ears. It does this by making tiny air molecules vibrate, like when you shake a ball of jelly. These vibrating molecules carry the sound to our ears so we can hear it. Let's take the example of how actually the sound travels. In the first step, the drummer beat the drum. What will happen? The drum vibrates. When the drum vibrates, the air molecules are squashed together. It means the air molecules are compressed together. So, when the air molecules are compressed together, what will happen? The air molecules spread out again, and in the last step, the sound spreads out in all directions. So, in this way, sounds can travel. Did you know dolphins communicate by sending out high pitched squeaks and clicks which travel through the water? Sound is a wave. When we say sound is a wave, we are describing how sound travels through the air or other mediums. Sound waves are vibrations that travel through a medium like air, water, or solids. These vibrations create changes in air pressure, which our ears detect and interpret as sound. So, understanding sound as a wave means recognizing that it travels in a wave like pattern. Similar to ripples in water, when you throw a stone into the water and it requires a medium to propagate. The other example of sound waves, when the cone of a loudspeaker vibrates, it moves in and out very quickly, stretching and squashing the air. So, the stretches and squashes of the air are called sound waves. So, these are sound waves. When they reach our ears, they make our eardrums vibrate and we hear them as sound. Model of a sound wave. Sound waves are a series of compressions and rarefactions. So, what is compression? When a loudspeaker squashes the air in front of it, the air molecules are forced closer together. This is called a compression. When the loudspeaker stretches the air, the molecules are spread out. This is called a rarefaction. Let's explain compressions and rarefactions in a spring wave model. Compression occurs when the coils of the spring are pushed closer together, resulting in a region of higher density or pressure. Rarefaction occurs when the coils of the spring are spread apart, creating a region of lower density or pressure. Compression and rarefaction start with the slinky spring in its natural relaxed state. Push one end of the spring towards the other end, compressing the coils together. This action represents a compression in the spring wave model. After compressing the spring, pull end back to its original position, spreading the coils apart. This action represents a rarefaction in the spring wave model. What is wavelength? The distance between two compressions or two rarefactions is called wavelength. What is oscillation in a spring? An oscillation is a regular backward and forward movement or vibration of the spring. For example, swing move back and forth and seesaw going up and down. This is the example of oscillation. Thanks for listening, my dear students. Subscribe the channel Education Core.